So now we'll discuss the next topic, that is telescope and the different types of telescopes which are commonly used. Okay. So you know what is a telescope, right? So telescope is an optical device which enables us to see distant objects clearly, and it provides the necessary angular magnification that is required to see distant objects, right? So the different types of telescopes that are generally in use are: one is called refracting telescope. Under refracting, you have astronomical and terrestrial. And the second one is called as reflecting telescope. And as the name suggests, reflecting means they need to use the mirrors. So they make use of converging mirrors to view distant objects. The examples of them are Newtonian and Cassegrain telescopes. Okay. So we are going to discuss mainly about the astronomical telescope. Are you guys able?
Yes. Yes, sir.
So now we'll see what is an astronomical telescope, and we'll try to give its construction and the ray diagrams to support it. Okay. So an astronomical telescope is basically a refracting type telescope which is used to see heavenly objects like stars, planets, and satellites. Okay. And basically, when you look at the construction of it, this also consists of two lenses. One is called converging lens. These also consists of two lenses. One is called objective and the second is called eyepiece. And both the lenses are converging lenses which are mounted coaxially at the outer ends of the two sliding tubes. Okay. So what does an objective do here is, it is a convex lens. If you see compound microscope, there also we have an objective that is also a convex lens, but of smaller focal length. Here it is a convex lens of large focal length and a much larger aperture. Okay. So it is the one which faces the distant object. And in order to form bright image of the distant object, the aperture of the objective lens is also taken slightly large so that it allows more amount of light to pass through it. So more the aperture, more will be the light passing through it, and more is going to be the brightness of it. Second is eyepiece. So it is a convex lens of small focal length and small aperture. Small focal length and small aperture, and it is the one which faces the eye. Okay. So the aperture of the eyepiece is taken small so that the whole light of the telescope which has entered the eye for distinction. Okay. Listen. So when the final image is generally formed at the least, so here also you'll be observing the final image being formed at two positions. One is called as the least distance of distinction, and the second is called as infinity. So generally, when the final image is formed at the least distance of distinct vision, then what will happen is, 1 minute. Yeah. See, if you look at the ray diagram, generally objective focus is at distant objects, right? So the ray comes from distant object like this. And after undergoing the refractions, the final image, when it is getting formed at point D, that is formed at a distance D, which is the least distance of distinct vision. Now we are going to calculate what is the magnifying power of this. So you remember what is magnifying power? Magnifying power is defined as the ratio of the angle subtended by the image at the eye to the angle subtended by the object at the eye. So it is beta divided by alpha, or to be more specific, I can write it as tan beta divided by tan alpha. Okay. If you see, the angle subtended by the object at the eye is alpha. So if this is alpha, the vertically opposite angle is also alpha, right? And if this is beta, that is going to be the angle subtended by the image at the eye. Okay. Now observe. When I apply the lens formula, for eyepiece, that is 1 by V minus 1 by U is equal to 1 by F, then I'll have 1 by B is minus D minus 1 divided by U is minus UE is equal to 1 divided by the focal length of the eyepiece is FE. So here I will have 1 divided by UE is equal to 1 divided by FE plus 1 divided by D. And if I take that 1 by FE outside, then 1 by FE into, I'll have 1 plus FE divided by D. Okay. So make a note of this point. Okay. Next is if you see, what is the magnifying power? It is tan beta by tan alpha. So for tan beta, I will take this right angle triangle. So tan beta will be equal to height of the image h divided by f naught divided by tan alpha is going to be, for tan alpha, I'll consider this right angle triangle. I'll use another color, see. Okay, which will be h divided by fe. H and h will get cancelled. Magnification will be equal to fe divided by f naught. 1 minute. I'm sorry, I made a mistake. H divided by UE. It is h divided by, this distance is UE. H divided by UE divided by, with respect to tan alpha, it will be h divided by f naught. So h and h will get cancelled. It will be f naught divided by ue. So when I observe this, magnification will be equal to f naught into 1 by ue, which I can write it as f naught into, in the place of 1 by ue, I can write it as 1 by fe into 1 plus fe divided by d. So this will be f naught divided by fe into 1 plus fe divided by d. So this will be the value of magnification produced by the telescope. Okay. Similarly, if the adjustment is done in such a way that the final image is formed at infinity, then how is the ray diagram going to look like? It is going to look like this. So when the final image is formed at infinity, then the image, the first image that is formed due to the objective, will exactly coincide with the focus of objective and the focus of the eyepiece as well. So from this, it is very simple to calculate. If you observe magnification, again it is tan beta by tan alpha. And for beta, I will take this triangle. So tan beta will be equal to h divided by fe, and tan alpha will be equal to h divided by f naught. H and h will get cancelled. You will have f naught divided by fe, but you will have again a negative sign because the final image formed is inverted. Is that point clear?
Yes, sir.
So make a note of all these points. First copy the diagram, then write down the magnification value. Done?
Yes, sir.
So when the image is formed at infinity, it is also called as normal adjustment because when the image is at infinity, right, you will be able to see it in a relaxed position. Okay. So having these points in mind, let's try to find the magnifying power. Let's try to solve some problems. The magnifying power of an astronomical telescope in the normal adjustment is 100. So normal adjustment means the image is formed at infinity. So in the case of normal adjustment, what is the magnification? It is f naught divided by fe. So magnification here is 100 is equal to f naught divided by fe, which implies F naught will be equal to 100 times Fe. But we need to understand one thing. The distance between the objective and the eyepiece is given as 101. So in this case, what is the distance between the objective and the eyepiece? It is F naught plus Fe is 101, which implies 101 Fe is equal to 101. Because in the place of F naught, I can substitute 100 Fe. So 101 and 101 will get cancelled. Fe will be equal to 1 centimeter. So when Fe is 1 centimeter, what will be the value of F naught? F naught will be 100 centimeter, because F naught is equal to 100 times Fe. Shall we proceed to the next one?
Yes, sir.
So try the next one. So example 133, there is an amateur astronomer wishes to roughly estimate the size of the sun using his crude telescope consisting of an objective lens of focal length 200 centimeter. And an eyepiece of focal length 10 centimeter. By adjusting the distance of the eyepiece from the objective, he obtains an image of the sun on the screen 40 centimeter. So VE is 40 centimeter behind the eyepiece. Okay. The diameter of the sun's image is measured to be 6 centimeters. So diameter is measured to be 6 centimeter. What is the estimate of the sun size given that the average Earth sun distance is 1.5 into 10 power 11 meter? So how to solve this? So there are two objects, there are two lenses here. One is objective and the second is the eyepiece itself. So when I take the objective, its focal length is 200 centimeter, and for the eyepiece it is 10 centimeter, right? And VE is how much? So this distance VE is equal to 40 centimeter. So is it positive or negative?
Positive.
Because they use the word behind the eyepiece. Positive now. Calculate where was the image formed before the eyepiece. So for that, apply 1 by VE minus 1 by UE is equal to 1 by FE. 1 by VE, 1 by 40 minus 1 by UE is equal to 1 by FE is 10. So 1 by UE is equal to 1 by 40 minus 1 by 10. How much is that? Minus 30 divided by 400, or UE is minus 40 by 3 centimeter. So this distance is 40 by 3 centimeter. So 40 by 3 is 13.33 something. So it is formed even before the focus. Okay. Now what is going to be the magnification produced due to the eyepiece? Magnification due to eyepiece according to Ben's formula is VE divided by UE. VE is how much? 40 divided by UE is minus 40 by 3, cancel these two, so it is minus 3. So minus is coming because you have an inverted image. Okay, so he measured the diameter of the sun to be 6 centimeter, right? Actually, what is the diameter? So what is the diameter formed in the image by objective? So it is only 1/3 of magnification. It will be 6 by 3, which is 2 centimeter. So it is 2 centimeter. Okay. Next is, if this is sun and these distances are taken to be capital D, and if this angle is alpha. Okay. So what is the value of alpha here? Alpha is measured in radian. So alpha is arc length divided by the distance. So arc length is how much? Arc length is 2 divided by, oh, sorry. Stick. By the value of so if I take this to be capital D, then this is the average distance they are given. So capital D divided by distance. So capital D is what we need to calculate, the original diameter, divided by distance is how much? 1.5 into 10 power 11. So this alpha is the angle subtended by the sun due to the objective. Okay. Then what about but we know this fact, right? So when the image is formed behind, see, if you observe, what is alpha actually? Alpha is size of image formed due to objective divided by the focal length of it, divided by f naught, right? So what I can do is I can write alpha is equal to size of the image formed due to the objective divided by f naught. Size of the image formed due to the objective is 2 divided by f naught is how much? 200. So this is 1 by 100. So what I'm trying to say is this alpha and this alpha are the same. So D divided by 1.5 into 10 power 11 is equal to 1 by 100. It will get cancelled twice. So which implies diameter of the earth is 1.5 into 10 power 9 meter. So this is a slightly tricky problem. Next is, actually, though it is written as IIT, I think you guys can solve this. Try to collect the data and solve it. A telescope has an objective of focal length 50 centimeters. So f naught is 50 centimeter, and eyepiece of focal length 5 centimeter. It is not tire, it is THE. The least distance of distinct vision is 25 centimeter. The telescope is focused for distinct vision on a scale 200 centimeter away from the object. So U naught is equal to minus 200 centimeter because it is kept on the left hand side. Calculate the separation between the objective and the eyepiece. So what is the separation between objective and eyepiece? So where is the image formed? The image is focused for distinct vision. So when it is focused for distinct vision, the distance will be d plus. So when it is like this, so the distance will be f naught plus UE. So that is going to be the distance between the objective and the eyepiece when the image is formed at the least distance of distinct vision. Try to solve this. For finding UE, what we need to do? First, find out where the image is formed due to the objective. 1 by V naught is equal to 1 by U naught plus 1 by F naught. So 1 divided by U naught is minus 200 plus 1 by F naught is 50. So it will be minus 1 by 200 plus 4 divided by 200. So it is 3 divided by 200. This is V naught. So V naught will be equal to 200 divided by, this is 1 by V naught. It will be 200 by 3 centimeter. Okay. Similarly, applying the lens formula 1 by VE is equal to 1 by UE plus 1 by FE. For eyepiece, I'll have 1 by VE is how much? It is minus 25 is equal to 1 by UE is what we need to find plus 1 by FE is how much? FE is 5. So 1 by UE will be equal to minus 1 by 25 minus 1 by 5. So this will be 525 minus 6 divided by 25. So UE will be equal to 25 divided by 6 with a negative sign. So these many centimeter. So what is going to be the distance between them? What is separation between the objective and the eyepiece? It is F naught 50 plus 25 by 6. Right? 50 plus, oh, sorry. Here it will be V naught plus UV. Sorry, I need to correct it. So this distance, where is it? In this scenario, this distance will be V naught. V naught plus UE should give you the answer. So what is the value of V naught that we have calculated? It is 200 by 3 plus 25 by 6. Okay. So multiply this with 2, here 2. 425 divided by 6 will be the answer. So whatever you're getting, calculate that value. Now what we need to do is you need to calculate the magnification produced. So magnification is obviously the product of M naught and MT. Do that, you will get the answer. Are you clear?
Yes, sir.
So we'll do one last problem. Actually, with this, the chapter is over. Okay. So read the question and try to do it. The small telescope has an objective length of focal length 150 centimeter. So f naught is 150 centimeter and eyepiece of focal length 5 centimeter. If this telescope is used to view a 100-meter high tower, so height of the object is 100 meter and UE is 3 kilometer with a negative sign. Find the height of the final image formed when the final image is formed at. So U naught is minus 3. So VE is minus D or minus 25 centimeter. Okay. How to solve this? So magnification produced due to the eyepiece is how much? Height of the image formed by the eyepiece divided by height of the object. So HI will be equal to ME into height of the object that is produced by the. So first we need to calculate what is the height of the object produced by the objective. So how to calculate it? 1 minute. I'll take this diagram. Why the page is not getting. So if you observe this, okay. So magnification produced due to the eyepiece is HI dash divided by HI. So to calculate HI, right? So to calculate HI, what we can do is we can take this right angle triangle. So if you take the right angle triangle, then tan alpha will be equal to HI divided by F naught. So what is the height of the image formed? So I can also take this length. So this is also alpha, this is also alpha. So if this height is 100 and this distance is 3 kilometer, is it 100 kilometer or 100 meter? 100 meter. No? So I can also take this value. Tan alpha will be equal to H naught divided by U naught. So H naught is 100 meter divided by U naught is 3000 meter because 3 kilometer. No? So it will be 1/30th of a radian. But this will also help us. So alpha also gives us height of the image formed divided by F naught, which implies HI is equal to alpha into F naught. Alpha is how much? 1/30 into F naught is how much? 150. So height of the image formed due to the objective is going to be 5 centimeter. And we know that the magnification produced due to the eyepiece is 1 plus FE divided by D. So 1 plus focal length of the eyepiece is
5 cent.
5 divided by 25. Wait. Actually, this will act as a simple microscope, right? So when it is going to act like a simple microscope, it will be 1 plus d divided by f. So 1 plus d is 25 divided by 5, which is going to be 6. Okay. So height of the image formed divided by the height of the object will be equal to 6, which implies hi dash is equal to 6 into hi, which is 5. That will give you 30 centimeters. Okay.
Yes.
So this is all about ray optics and different kinds of optical instruments. Okay. Next class, that is on Monday. But next week I might conduct a test in this chapter.
Okay.
Okay. So keep preparing. Okay.
Yes, sir.
So I'll see you all on Monday. So from Monday
Okay.
you'll be having offline only. You can come there.
Sir.
Office, academy. So keep coming, can come. That's what I'm saying.
Okay.
Okay. We'll wind up.
Okay. Thank you, sir.
Thank you, sir.